Hello everyone, welcome to our fourth lesson, which is multiplying and dividing by skip counting. In this lesson, we will multiply by skip counting and we'll divide by using repeated addition and skip counting. So you've likely seen something like this already before. It's showing skip counting on a number line. So if we look at this, the question we first want to ask is what number is being added repeatedly? So if we're starting at 0, jump to 2, then we're jumping 2 more and 2 more. So the number that's being added repeatedly is 2. The second question asks, how many times is it added? Well, how many jumps do we have? 1, 2, 3, 4, 5 different jumps. So it's being added 5 times. Now, do you see a multiplication in this number line? I hope you do, because we have 2 being added 5 times. And we know that 2 times 5 will equal 10, and that's where we end up on the number line. We end up at the number 10. So here's another way to look at it. It asks us, what does the 5 represent? And this is the same as the last one. So the 5 represents the number of jumps that we had. And what does the 2 represent? The 2 is how much we are jumping each time. What would we write after the equal sign? Well, that's where the 10 goes, right? Because we know that 5 times 2 equals 10. And that's where we end with our jumps. Okay, so now this question asks us to show these products on number lines. So going by what we had before, if we have 6 jumps, the length of 2 spaces each, then let's try that out. Starting at 0, we're going to jump 2 to 4, that's 2 jumps, 3 jumps, 4 jumps, 5 jumps, and 6 jumps. So then we know that 6 times 2 will equal 12. On the bottom one here, we have 3 jumps of 4 spaces each. So jumping to 4, there's 1 jump, there's 2 jumps, and there's 3 jumps. So 3 times 4 is again 12. Now, could we do this a different way? Could we say 4 jumps of 3 and get the same amount? Let's try it. There's 1, 2, 3, and 4. And yes, we do. Just a little note, we call that the commutative property of multiplication. It doesn't matter which order we do it in. We can do 3 times 4 or 4 times 3, and it will still give us the same answer each time. Now on this page, it's asking us to draw arrows to show skip counting by 3s. So let's try that out. 3 to 6 to 9 to 12, 15, 18, 21, 24, 27, and 30. And then we can use that to find the multiples of 3 by counting arrows. So 5 times 3, well, I didn't draw the arrows on the end. We could draw the arrows in there, but we can count the jumps. So counting the jumps, if we count 1, 2, 3, 4, 5 jumps, 5 times 3 is 15. 2 jumps, 1, 2, will land us at 6. 6 jumps, 1, 2, 3, 4, 5, 6, will land us at 18. And 4 jumps, we did that on the last slide, but let's try it again. 1, 2, 3, 4 will land us at 12. We can also use our hands to skip count by 3 up to 30. So we can we'll start on the very left here, and we can count 3, 6, 9, 12, 15, 18, 21, 24, 27, and 30. So using that, we can then count on our hands to find these multiples of 3. So if we do 5 times 3, we're going to count up 5 fingers. 1, 2, 3, 4, 5 would be 15. 2 times 3, counting up to our second finger, would get us to 6. 6 times 3, counting to our 6th finger, 1, 2, 3, 4, 5, 6, gives us 18. And to our 4th finger, 1, 2, 3, 4, gives us 12. So this slide asks us, is it easier to multiply by 3 on a number line or on your hands, and why? Well, 3 we could do it either way, right? But do you always have a number line handy? Or do you always have paper where you can write down the numbers on a number line, but you always have your hands with you, right? It's a little bit easier to count on your hands if you need to than it is to use a number line. For example, if we tried 7 times 9, that would require a number line that goes all the way to 63. So that would take up a lot of space and a lot of time, but only 7 fingers would be needed to skip count on your hands. Here are some problems to help us to practice. So it asks us to use multiplication to solve the problems. And a little hint there says knowing your times tables will help you solve problems that otherwise require a good deal of work adding up numbers. So if you know your multiplication tables or times tables, then this should be easy for you. If you don't, I would really encourage you to work on that and make sure that you know them by the end of this year, because it'll just make all your math from now on till the end of university even easier if you know your multiplication tables. So for A, it says there are 4 pencils in a box, and how many pencils are there in 5 boxes? Well, we could take all the pencils out of the box, count 1, 2, 3, 4, 5, and so on. But if we know there's 4 in one box, and there's 5 boxes, then we could multiply those two numbers together, because 5 is like a group. The number of boxes is like the groups of boxes that there are, or groups of pencils. 4 times 5 will give us 20. And again, if you're not sure, you can count on your fingers, but I would encourage you to know your multiplication tables automatically. A stool has 3 legs. How many legs are on 6 stools? A stool has 3 legs. Each stool is like a group. 3 times 6 will equal 18. So there's 18 legs on the stool. Who cares? Well, maybe if you're buying like a felt pad to go on the bottom of the stool, you might need to know that. A boat can hold 2 people. How many people can 7 boats hold? Here the boats are the group. So 2 times 7 will equal 14. On this slide, we're reviewing division. So here we have 15 counters, these little red circles. And if I want to divide them into sets of 3, then we want to circle 3, right? Because sets of 3 means we want 3 in each group. So we'll carefully draw our circles around each 3. Those ones overlap a little bit, but we just have to be careful what we're doing, and we know that that's 2 separate groups there. And there we go. So how many sets do we have? How many circles did we draw? 1, 2, 3, 4, 5. And so as it says on the bottom, 15 divided by 3 equals 5. And we can write that in words. 15 divided by 3 equals 5. Okay, this one here asks us to write a division equation for the illustration. Remember, when we're talking about an equation, we need to have an equal sign in it. Otherwise, if there's no equal sign, it's just an expression. So those are 2 slightly different things. So we're going to start with how many things we have in total. Here we have 9 dots. We've divided them into groups of 3, and we have 3 in each group. So 9 divided by 3 equals 3 would be our division equation. In B, we started with 10 lines, or maybe they're 10 sticks, divided them. I'm not sure why that just erased, but that's okay. So we started with 10 sticks there, and we're dividing them into 5 groups, and we have 2 in each group. We could say we're dividing them into groups of 2, and we have 5 in each group. Either way works. For C, this one looks like a little bit of a tricky problem at first, but let's look at it and figure it out. How many triangles do we have? There's 9 to start with, so 9 triangles. How many groups did we divide them into? 1 group, and all 9 of them are in that same group. So this one is 9 divided by 1 equals 9. Looks a bit tricky at first because we don't usually divide things into 1 group, but it's actually quite simple. D also looks like it's a tricky one. We start out with 4 squares. We are dividing them into 4 different groups. And so how many do we have in each group? If we've divided them into 4 groups, there's 1 in each group. Okay, in this one it's asking us to illustrate or draw the division equation. So if we start out with 6 things, let's start with 6 sticks. 2, 3, 4, 5, 6. And we want to divide them into 3 groups to have 2 in each group. So there's 1 group, 2 groups, and 3 groups. Just like that. Same thing with B. If we've got 15 things to start with, again, we'll start with sticks. 1, 2, 3, 4, 5. And to make it easy on myself, I'm going to draw them into groups of 5. Okay, so we've got 4 there, and there's 5. 1, 2, 3, 4, 5. And 1, 2, 3, 4, 5. And so that puts them automatically into 3 different groups. So we can just circle them this way, and there we go. Our 15 divided by 3 equals 5. Because of my pen, I'm not going to do C and D, but you get the idea of how to do those. If you have questions, you can always ask me too. We can also show division by skip counting on the number line again. So if we want to look at 18 divided by 3, then we're going to skip count by 3s from 0 all the way to 18. And here's your hint. How many skips of 3 does it take to reach 18? 1, 2, 3, 4, 5, 6. So our answer will be 6. We use the number line to skip count by 3 to 18, and then we count the number of arrows. Here's another example for us. Let's use this number line to find 10 divided by 2. So we're going to skip count by 2s up to 10. 4, 6, 8, 10. Now I could continue on, but how do I know when to stop? Well, when I get up to the number that we start with here, right? We're at 10, so that's where we start. How many skips do I have? 1, 2, 3, 4, 5. So 10 divided by 2 is 5. And we can do the opposite as well. What problem does this number line represent? Well, we've got jumps or skips of 4. And how far did we go? How many jumps are there? 4 times 1, 2, 3, 4, 5. So 4 times 5, which equals 20. Now we've got it. So for a division question, we could add 20 divided by 4 equals 5. Or we could do it the other way around. 20 divided by 5 equals 4. If we wanted to write an addition question, we could write 4 plus 4. And how many times are we going to do that? Plus 4 plus 4 plus, you've got it, 5 times, which would also equal 20. We can also divide without a number line by skip counting on our fingers. So for example, the problem 15 divided by 3, your hint is to skip count by 3 until you reach 15. And the number of fingers you're holding up when you reach 15 is the answer. So here it shows it on the screen with dots. If you count 3 plus 3 plus 3 plus 3 plus 3, that will equal 15. And you could do by adding up that many fingers. And again, here are some problems to finish off our lesson. And we can use division to solve these problems. If there are 5 friends who share 30 tickets to a sports game, how many tickets does each friend receive? So if we start with 30, we're going to divide those tickets among 5 friends. One way to do that is to count up by 5s with your fingers. So 5, 10, 15, 20, 25, and 30. That's 6 fingers that we used to count up. So we know that 30 divided by 5 will be 6. So each friend will receive 6 tickets. In B, we have 20 friends who sit in 2 rows at the movie theater. How many friends sit in each row? 20 friends divided among 2 rows. And again, we can count it up. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. We used all 10 fingers, so we know that 20 divided by 2 will be 10. In the last one, number C, $50 is divided among 10 friends. How much money does each friend receive? We're starting with $50 divided among 10 friends will be how much? Counting up again, 10, 20, 30, 40, 50. So we used 5 fingers, so each friend will receive $5. And that concludes this lesson. So now you can go to your workbook and do pages 9 to 10. And again, let me know if you have any questions or any problems with these pages, and I can help you out with them. See you next time.